So far in the last session, we have started the approximate analysis, and in that session previously we studied the portal frame method. In today's session, we are going to see the next method for analysis of the frame, or this cantilever method. So both these methods are simultaneous to us for analyzing the same structure. But only thing is that in portal frame method, first we determine horizontal reaction H, and then we start analyzing the frame by using equilibrium equation, and we determine unknown forces in the remaining members. But if we consider in the cantilever method, so first our aim is to find out the vertical forces in a member. Okay, so basically here also there are some assumptions made in this method. The cantilever method is suitable if the frame is tall and slender. So that we already know that the frame is the vertical horizontal members, beam and column are there. In the cantilever method, the following assumptions are made. An inflection point, so it is nothing but the internal hinge occurs at a mid height of each girder, that is each beam, and an inflection point, that is hinge, the point of counterflexure occurs at mid height of each column. So that assumption were same in the portal frame method as well as in cantilever method. Only third assumption is the difference. In a story, the intensity of axial stress in a column is proportional to its horizontal distances from the center of gravity. This is the assumption most important that we have to look into this. Okay, why this is the important assumption is there? Because here it indicates that the intensity of axial stress in a column is proportional to its horizontal distance from center of gravity of all the columns here in that story. Let us consider, suppose we have a frame like this. So what this statement says, that we will understand first, and then we'll try to implement all these assumptions, and we'll try to analyze the structure. Now these are the suppose the one structure is there. So according to third statement, axial stress. You know that the stress is equal to P into A, or P by A. Stress is equal to P by A. Okay. Stress is equal to P by A. So what this statement says, that the stress in a column is proportional to its horizontal distance from the center of gravity of all columns. Now let us say that suppose this distance is 6 meter and this distance is 6 meter. Or we have this let us make this that this distance is suppose 8 meter. For every member, its x-axis is there. But for if we compare the entire structure, its CG will be different. CG of entire structure. How we can find out the CG of combined member? The formula is x bar is equal to A1 x1 plus A2 x2 plus A3 x3 upon A1 plus A2 plus A3. Now here A1, A2 are the A is nothing but area of column. And always, if area of column is not mentioned to you, in that case we have to consider this area of column is 1, unit 1. If the area of column is not given to us, so we can consider area of column is 1. Okay. Now x1, x2, x3 means that we have to locate the CG from the surface. So x1 will be here, x2 is the distance this, and x3 is the this distance. And once we get an x bar, we'll get something x bar over here. This is the CG of the entire structure, x bar. Now what it indicates? It indicates that the stress in this member, and stress in these members are proportional to their distance from centroid. Okay, x bar to member force. Distance of the member and x bar, this is proportional to this. So it indicates, suppose let this is P1, this is P2, and this force is P3. Let this distance is A, this distance is B, this distance is C. So according to third assumption, it will establish a relation like it is P1 upon A is equal to P2 upon B is equal to P3 upon C. Yes. So this is the relation will be established by assumption number 3. And now once we have these assumptions from that, and if we take a moment about any point of contraflexure, then we can find out the P1, P2 and P3. Once you know this vertical reaction P1, P2, P3, so again as our usual procedure, we'll draw the FBD. Now this force is known to you. This is your horizontal force. Now what we have to find out? DCH, here vertical reaction by applying summation Fy, and if there is horizontal reaction by summation Fx is equal to 0. So overall procedure will be similar to this. Only thing is different between the portal frame method and cantilever method is initially in the portal frame method we assume horizontal shear taken by interior column is twice than the exterior column. But here instead of taking the horizontal reaction or horizontal shear, it is based on the axial stress in column is proportional to its horizontal distance from the center of gravity of all column in that story. So considering this, our interest is to find out the forces. By considering this, we can establish a relation. First, we find out x bar, then establish relation between forces and x bar. No doubt, this will be again carried out according to this story. First, we'll carry it out for upper story, then we'll carry it out for lower story. Because of this, there will be different axial forces in this member also and in the above story also. Okay. So hoping that you understood the concept. What is basically cantilever method? Why these assumptions are there and what will be happen because of this? Okay. Understood this concept? If yes, then we take a problem. Otherwise, I will again explain you this concept to you. Is it necessary to explain again this concept of cantilever method? Repeats. Okay. Good. Okay. Okay. Again, we'll go by some slowly. See that. Suppose we have a frame like this. Now we have to analyze this frame. Let us consider that two horizontal loads are acting over here. In cantilever method, we have to find out the CG of frame. In cantilever method, our interest is to find out, first interest is to find out the center of gravity of frame. And center of gravity of frame, you know that how to find out the x bar or y bar for equal and unequal sections. Okay. Now if we have to find out this, and that we have to locate from the first column. We have to locate it from this column. Okay. If this is column number 2, this is column number 3, this is column number 1. Okay. Now from that, our interest is to find out x bar. Suppose this distance is known to us. Let us say that this is suppose A1. This distance is suppose A2. And we don't know the our interest is to find out the x bar, and you already know that individual members CG lies at these locations. Suppose in this case, now we have to look at from this, so x1 will be equal to 0. Here, if we consider this, x2 is equal to A1 and x3 is equal to A1 plus A2. And how to find the x bar? X bar is equal to A1 x1 plus A2 x2 plus A3 x3 and divided by A1 plus A2 plus A3. Why we have taken these three? Because we have only one column, column number 2 and column number 3. If in a frame, if there are larger than this number of columns, then we can take larger number of areas. Understood this x bar? Okay. Now it is x bar is this. Now next is according to assumption number 3, what we have to do is first we will consider upper story only. If we have in this upper story, if we consider this, okay. Let this is our point of contraflexure and over here and one load acting over here is supposed to be. Now we know this x bar which will be lies somewhere here. That will be suppose this is our distance of x bar. Okay. Now here towards this side we assume that the reactions are in downward sense and beyond this x bar reaction will be in upward sense. Let this is V1, let this is V2 and let this is V3. Okay. Now this distance is x bar, you know this distance is your A1, from this distance is it is A2. Now according to assumption number 3, these vertical reactions are proportional to their centroidal distance from this. V1 is based on divided by x bar is equal to V2. V2 is x bar minus A1 is equal to V3. We can say that for V3, A1 plus A2 minus x bar. This will be the relation will be established among these three forces. This will be the relation we establish between three forces. But this will not give you the result. But what will happen? Suppose we can take moment about any one point. Suppose we take moment at about this force. Then we'll get equation in terms of V2 and V3. But we have a relation for V2 and V3. Anyone can be converted in terms of V3 or V3 can be converted in terms of V2 and then we'll get V2, V3 and by using this relation, by knowing any one of force among these three, we can find out remaining three. And once we get V1, V2, V3 and then we can, remaining procedure is to draw a FBD and find out horizontal and vertical reactions. Understood? Understood it? Okay. Now let us take a problem. Okay. Analyze the frame as shown in figure by cantilever method. This distance is 6 meter, this distance is 4 meter. One load acting over here is suppose 40 kilonewton. Another load is of this 20 kilonewton. Then height of this column is suppose 6 meter, first height. and remaining height is suppose 4 meter. And the notations are given A, B, C, D, E, F. And remember that the in exam also these questions are to each other. Okay, either you can solve that same problem by using cantilever method or by portal method. Okay, GHI. So this is the frame which is given to us. So according to this, we have to solve this problem. So first, our aim is to find out the x bar. First thing is that what we have to find out is x bar. That is according this formula is a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. And always remember that if area of column frame is not mentioned in a problem, always consider a1 is equal to 1. Okay. Now here x1 will be here, x2 will be the distance from this to this will be the x2, and third distance will be x3 over here. Okay, so considering this, a1 1 into x1 is 0 plus a2 is the second column, 1 is the area, x2 is 4. Change this distance, this is not 4 and 6, it is actually 6 and 8, 6 meter and 8 meter. We can take different, but our answers we have to tally the answers also. For that purpose, I have taken these distances. Okay. Okay. 1 into 6 plus next for this C column number C joint C the 1 is the area into distance. This x3 is 6 plus 8, that is 14 divided by a1 1 plus 1 plus 1. How much it is to be coming? 6.67. Very good. Now this is suppose 6.7 meter. Okay. We'll write down here only consider upper story. See that these problems are lengthy, but it is easy to solve. Considering upper story, suppose we consider only upper story. There are 3 members. Okay. And one horizontal load of 20 kilonewton acting over here, and this distance is of 2 meter. And we have determined x bar. Let us see that x bar is somewhere here. That is at 6.67 meter. Now, beyond this x bar, the all forces will consider in a downward direction. And towards this right hand side of this, we'll consider this as a upward direction. Okay. And in upper story, if we have this G, is the notations for joints are like G, H, and I. So we can find out the forces. Here we instead of that we name this as a VGF, VHE, and VID. Vertical force in ID, vertical force in HE, vertical force in GF. Okay. And individual distance, you already know for this distance is 6 meter, and for this distance is 8 meter. Now, according to the our third assumption, we can have a relationship like VGF is equal to, where is locating VGF from this. Now, all distances we have to measure from this axis, from this X bar. We have to measure the all distances from this. So, from this VGF is located at a distance of 6.67. Next is VHE, where it is located at a distance of this much, and this distance is nothing but 6.67 minus 6. And third force is, yes, very good, VID upon this distance. Our interest is to find out this distance, and that will be equal to 14 minus 6.67. So this is VGF upon 6.67. Good. VHE 0.67 is equal to VIT on 7.33. Now we have a relation this. Now let us take a moment about point of contraflexure in member you can take at any location member ID. I am locating over here. So our aim is, my targeting is that I am going to take movement at this. ID I will consider as 0. These two are moving in same direction, and 20 is in the opposite sense. These two are moving in anti-clockwise direction. 20 is moving in a clockwise clockwise sense. So let us consider that. Suppose VGF into, I'm considering anti-clockwise positive, or vice versa. We can consider that. That doesn't matter. Okay. Okay. Let us consider according to our convention. So like minus VGF into 14 minus PHE into 8 plus 20 into 2. Remember this. PGF is moving in this direction. VHE is also moving in this direction, and this 20 will be moving about in a point is this distance. And how much is the distance from 20 to this perpendicular distance is 2 meter. For this distance is the 8 plus 6, 14. For this distance is 8 meter. So this will be the relation, and that is equal to 0. So what relation we can use here? We have a relation VGF is 6.67 is equal to VHE 0.67. From that, what you can establish? Either you can convert VGF into VHE. Okay, let us consider that VGF is equal to 6.67 VHE divided by 0.67. How much it is coming? 9.955. Okay, so VGF is equal to 9.955 VHE. Okay, here. Now VGF we have this slide. Let us write down this minus 9.955 VHE into 14 minus 8 VHE plus 40 is equal to 0. Can you solve this equation? And can we find out that VHE is equal to? How much it is coming? VHE is equal to 0.27. Very good. VHE is equal to 0.27 kilonewton. Okay. Now we know that VHE. So VGF is equal to. It is 9.955 into 0.27. So we'll get VGF. That is 2.687 kilonewton. Very good. Yeah, somewhere 2.70, 2.687. These both are answers correct. 2.7 answer is the correct answer. Okay. And third relation we can establish from the third is V. But we have another relation is suppose VHE upon 0.67 is equal to VID upon 7.33. Okay. So VID is equal to VHE into 7.33 divided by 0.67. So just put the all values. VID is equal to VHE is 0.27 into 2.95, 7.33, 2.95. Okay, good. 0.67. VID is equal to 2.95 kilonewton. Very good. Very good. Now next is once we get VID, VHE is known to us, VID, VGF. All these three forces are known to you. Then draw a FBD for a given structure. Now next analysis is similar to previous one that we already studied. Okay, these are all our point of contact lectures. Now very good thing is that we have determined these vertical reactions. This is upward. Okay, this is 2.95. This is 0.27 and this is 2.687. Okay, and we know that the given load in this frame is of 20 kilonewton. This distance is 2 meter for all the members. Okay, this horizontal distance in the first phase will be 3 meter. This will be 3 meter. This is 4 meter. This is 4 meter. What is not known to us is at this internal hinge, this internal hinge, this internal hinge, and this internal hinge. One upward reaction that we don't know will be downward, downward. So there will be upward. This will be in a downward sense. Then let these two horizontal forces, horizontal reactions are not known to us. This horizontal is not also known to us. This horizontal is also not known to us. Okay, our interest is to find out these forces. Okay, we can give the name to this H, G, F. Okay, F, H, E, horizontal force in H, E, HID. HID, horizontal force in ID member. This is vertical force in which member? That is GH. GH. This is vertical force in member HI. This is horizontal force in HGH and this is horizontal force in HI member. Okay, so let us start. You already familiar how to carry out this process. Divided this in three parts. Okay. In first case, now our interest is to find out VGH. We can apply summation Fy is equal to 0 first. So upward force positive, downward force negative. So VGH is equal to 2.687 kilonewton. Directly we can write down this. Understood this VGH? Vertical reaction. This VGH is 2.687. Yes or no? Okay, good. And see that in exam, it is not necessary you have to perform this entire calculation. Okay, you can, if you are comfortable, you can directly calculate from on this also. Suppose we take moment over here right now. If we take moment at this point load, or we'll take moment of at this point of contraflexure, then we'll get HGH. Okay, this number is G. Let us write down this G is okay. Moment algebraic sum of moment about G is equal to 0. Now we are taking moment at this location. What are the forces? This will be passing from this HGF and this will be moving in this direction about G. And now vertically is moving in this. It is anti-clockwise. So minus 2.687 into 3 plus HG F into 2 is equal to 0 and that will give you HGF. .03, very good. Okay, 4.03. Now in these horizontal reactions, positive, negative. Okay, this is this positive and negative that we have to perform. So this in upper story, this is 20 kilonewton positive towards this 20 minus 4.03 minus HGH is equal to 0. So this HGH is equal to 15.97. Very good. 15.97 kilonewton. Okay. We have determined this. This is 4.03. This is 15.97. Now coming back to this joint, GH joint. Okay. What is not known to us is the VHI. So first we'll directly apply summation Fy is equal to 0. Upward force positive, downward force negative. So okay, so minus 2.687 minus 0.27 plus VHI is equal to 0. That will give VHI is equal to 2.95. It's 2.95. This is 2.95. Okay, over. Then about this horizontal are known to us. One horizontal is not known to you, so we can take moment about H. Okay. Let us take moment about H is equal to 0. Let us take moment about H is equal to 0, and which means that we are taking moment at this point. How many forces? See that This horizontal is passing through origin, so that will not create any moment. This horizontal is also passing through the origin, that is also not going to create any moment. And what are the moment creating forces? This 0.27 kilonewton, which is also passing as an axial load through H, so that is also not going to create any moment. So moment creating forces are HGH, these VGH, that will be moving in an anti-clockwise sense. So minus 2.687 into 3. Another force is this VHI, that will be also moving in a anti-clockwise, minus 2.95 into 4 plus HHE into 2 is equal to 0, and that will give you HHE is equal to 9.93 kilonewton. Okay, 9.93 kilonewton. And after this, we can apply directly summation Fx is equal to 0. This force is positive, this is negative. How many horizontals are there? First is the 15.97 minus 9.93 minus HHI is equal to 0, and that will give you HHI is equal to 6.04. And then HHI is equal to, okay, this you determined as a 9.93, 6.04. This HID is also, here also we can apply summation. Fx is equal to 0, then we will get HID is equal to 6.04. Okay, now upper story we have completed. Okay, now axial force in lower story, that is the next part that we have to determine. Axial force in lower story. Okay, so again draw the diagram similar to previous one, only we have to consider now hinge in a lower story. Upper story we will consider entirely, and then this will be our lower story. Okay. We have already located the x bar, that will be as it is now, it is fixed 6.67. Okay, this is 6 meter, next distance is 8 meter. We have to locate this force, this will be considered as a downward and this will be considered as an upward. And we'll write down this name for these forces are like, this force will be VAF, vertical force in AF. This will be VBE, and this will be VCD. And horizontal reaction, the horizontal load which is acting over this joint of 20 kilonewton, and at this joint is 40 kilonewton. This distance is 3 meter. Above that, this distance is 4 meter. In the diagram, this distance is larger one. In this should be an appropriate way. Okay. Now first we find out this axial force in VAF, PBE and VCD. Okay, PAF, PBA and VCD, these we have to find out as an first forces, and then we can analyze the frame in the previous one. Okay, now we have to establish relation. So what we can have like V VAF divided by 6.67. Initially, it will be only same. All the distances will be same. Only forces are going to be changed. VBE is divided by 0.67, and last one is 7.3. Okay, 7.33. This is VCT upon 7.33. Okay. Now we can take moment about point of contraflexure in member is CD, member CD. Okay. Now look here, in member CD, when we say the member CD, we are going to take moment about this point. Now this force is going to be 0. This will be going to move in the anti-clockwise sense. This will be moving in a clockwise sense. So minus VAF into 14 minus VBE into 8, okay, plus 20 into 7 plus 40 into 2 is equal to 0. That will give you minus 14 VAF minus 8 VBE is equal to 20 into 7, 140 plus 80. This is 2. Directly write down this plus 220. 40 into 3. Okay. This distance is not 2, it is 3. 40 into 3 is equal to 0. So 22. How much it is? 40 into 3. This 260. Very good. 260 is equal to 0. Now this is the equation we have, and if we use the two relations, VAF upon 6.67 is equal to VBE 0.67. So VAF is equal to 6.67 VBE divided by 0.67, and that gives us 9.95. VAF is 9.955 VBE. Just put all these values over here. Minus 14 into 9.955 VBE minus 8 VBE plus 260 is equal to 0, and that will give you us a VBE is equal to 1.76. Very good. Correct answer. 1.76 kilonewton. Then next is VBE is over. Now we can find out VAF is equal to 9.955 into 1.76. 17.52. Now we know the VBE, that is 1.67 upon 0.67 is equal to VCD So another shortcut you can use it 7.33. So we'll get VCD. 19.33. Very good. All answers are correct answers. So this is the difference between the portal frame method and cantilever method. Now, can you perform the second story analysis? If you are going to perform second story analysis, then we will not have this assignment problem. Otherwise, I will complete the second story or I will give one assignment problem. That is depend on you. Similar to upper one or previous one problem, you can perform this lower story analysis, or otherwise we have to I will complete this problem. Should I complete? Yes or no? Okay, good. Now we know these vertical reactions, so just again draw the FBD considering all possible joints. I will write down the name of joints for your understanding. Which joint we have considered? This joint is F joint. This joint is just we have used. Okay, correct. There F E F joint, E joint, and this will be our D joint. Okay, now we'll consider the internal hinge over here. Over here, right now, whatever the internal forces you have determined in this member, that will show first over here. VBE. Okay. Uh, this will be in a downward sense. This is also in a downward sense. This will be in a upward sense. This is 19.33. This is 1.76, and this force is 17.52. You check this whether we are writing this correct or right, wrong. Then this will be for horizontal and as well as for vertical. Okay, we'll show this vertical. Okay, first we'll write down the forces which are coming from the upper story. Okay, those are acting downward, that will be shown in upward. Okay. Likewise, forces will be coming from the upper story, and we have determined these forces. One is the horizontal is 15.97 and 2.867. 2.687. 2.687, and above force is 15.97. 15.97. Intermediate here 0.27 and this is 9.93. And this is the 2.95 last one 2.95 6.0. Okay, now these forces are whatever the forces we have to determine. Okay. Vertical forces will show in the red color 4.03. Okay, let us see this first. This will be acting downward, this downward, this downward, this will be upward, downward, this is upward. Okay, horizontal will show this. I haven't considered HGF. Ah, 4.03. Okay, 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 okay. 4.03. Okay, this is the unknown forces in red color, that is V, F, E, V, E, D. H, F, A, H, E, B, H, C, D. Because we have to determine these forces, unknown forces. Okay, what is remaining here? One force of 40 kilonewton, which is acting over here. Above distance is 2 meter, below distance is 3 meter. This is 3 meter, this is 3, this will be 4, 4, 2, 2, 3, and 3. Okay. We can apply initially summation Fy is equal to 0. Here upward force positive, downward force negative. Upward is 2.687, 2.687 plus VFE minus 17.52 is equal to 0. That will give you VFE is equal to 14.83. Okay, good. Then we'll take moment at F is equal to 0. We're going to take moment at this F point. So what will be 0? This 40 will be 0. This 17.52 will be 0. VFE we have already determined. This is 14.83. So minus 14.83 into 3 plus 4.03 into 2. First I have taken this force, then 4.03. 2.687 passing through origin, no moment. 40 is passing through origin, 17 is also passing through origin. Then HFA moving in a clockwise sense, so plus HFA into 3 is equal to 0. Here HFE is equal to and HED is equal to 12.1 14. 12.14. Very good. 12.14 kilonewton. Then this is 12.14. Then apply summation Fx is equal to 0. Force positive, negative. So force is 4.03 and 40 is also positive. 4.03 plus 40 minus 12.14 minus HFE. HFE is equal to 0. So this will give you HFE is equal to 31.89. Very good. 31.89 kilonewton. Okay. Again, similar to the previous one, we'll apply first summation Fy is equal to 0, upward force positive, downward force negative. Now only in this joint from this to this we have to consider only at joint E. Everything equilibrium equation will apply at only joint E. Here downward force, the first is minus 14.83 minus 1.76 plus 0.27 plus VED is equal to 0. So VED is equal to 16.32. Okay, VED is equal to 16.32. This is over. Then we take moment about a E. Moment about a E is equal to moment about E is equal to about this point we have to take a moment. The forces which are acting now will start from this 14.83 which is moving in anti-clockwise sense. So minus 14.83 into distance is 3. This is over. 1.76 is passing through origin, so that will not going to create any moment. Then we have HEB which is moving in a clockwise sense, so plus HEB into 3. Then coming back to this HED which is be passing through origin, so that will not create any moment. Then VED also moving in a anti-clockwise sense, so minus VED into 4. Then 9.93 which is moving in a clockwise sense plus 9.93 into 2 is equal to 0. So this much will be the forces, and that will give you a very good HEB is equal to 29.97 kilonewton. Okay. Then lastly we can apply directly summation Fx is equal to 0. Okay. The force which is 31.89 over here, this is minus HEB minus 29.97 minus HED that we have to determine, and again plus 9.93 in this force plus 9.93 is equal to 0, and then this HET is equal to 11.85 kilonewton. Okay, so HED is 11.85 kilonewton. If you come back to joint D, how many unknown forces are there? Only HCD. So we can apply directly summation Fx is equal to 0. Positive, this is negative 11.85 plus 6.04 minus HCD is equal to 0. So HCD is equal to 17.89. Okay, good. Kilonewton. So this is the way to analyze the entire frame. Now this, in this way we can find out the all the forces. So these are the equations that you can apply for analyzing the frame. If you observe this particular problem, this is lengthy problem, but all possible the determining of forces is very simple based on the simple equilibrium equations. Summation fx, summation fy, and moment at joint is equal to 0. In exam, it is not necessary. If you are comfortable to find out the all equation in calculator only, so you can complete that problem entirely on this joint only, not necessary. But after that, important aspect after analyzing the problem is to plot bending moment diagram, and that I already taught you to how yesterday to plot the bending moment diagram. So in the same, in similar manner, after lecture is over, you complete the bending moment diagram. Okay. So I will give one problem, simple problem to you for the analysis. Again by using cantilever method. This is 40 kilonewton, 15 kilonewton. Okay. So this is the portal frame. So this is the cantilever method of analysis. After lecture is over, I will going to put the lecture recording on Google Classroom so that it will be easier for you people also. For while solving the problem, you can refer that. Okay. Is anyone has any doubt related to this topic? If you want to ask any, want to ask something about this.